All right, this is Algebra lesson 9.9. It's titled Analyzing Functions with Successive Differences. Okay, I deleted yesterday's message and I didn't even put it on YouTube because I'm going to make this as clear as I possibly can. Okay, in 9.8, the lesson before this, they gave you numbers that were, 256, 128, 64, 32, etc. And they asked you to tell whether or not this sequence was arithmetic, geometric, or neither, right? That's what they asked you. Is it an arithmetic sequence? Is it a geometric sequence? Or is it neither? In this situation, how do you test for arithmetic? What am I looking for? I'm looking for it to be consistently addition, right? Consistently addition. This is minus 128. Is minus 128 addition? Yeah. Yes. Subtraction is addition, right? This is plus a negative 128. Agreed? And then this is minus 64. And you go, okay, what is this for sure not? This is not arithmetic, right? This is talking about sequences. So then you have to go like this and go, okay, look what you do. What you do to test it is you take the second number and you put it over the first. So this would be 128 over 256, which reduces to 1/2. And then you go 64 over 128, which reduces to 1/2. And then you have 32 over 64, which reduces to 1/2. So they're all 1/2s. They're all a half, which makes this geometric, right? The sequence is geometric because it's all being multiplied by 1/2. Does that make sense? Okay. If it doesn't arithmetic and it's not geometric, then you'd say it's neither. That's the end. We're talking about here, those were sequences. Does that make sense? Those were sequences. Arithmetic sequence or geometric sequence. Now, in today's lesson, we're not talking about sequences anymore. We're talking about functions. And yes, we did talk about this yesterday. I want to talk about it again. Let's go back to this. When we had an arithmetic function, when we had an arithmetic sequence, what do we call that common thread? What do we call the consistent thread? The common difference, right? When it's arithmetic, it's a common difference. What about when it's geometric? That's called a common ratio. Does that make sense? Okay. Here's our guy here. So I'm going to talk to Jem mostly because she wasn't here yesterday and you didn't look at anything, right? So you're just, okay. Right. I know. I didn't even put it on there. Here we go. You paying attention? Here we go. It's for you. Jem, what is this thing? What kind of a function creates that guy? A linear function makes a line, right? Okay. What kind of a function makes... First of all, what is that thing called? I'm talking to Jem. A parabola. So what kind of a function forms a parabola? A quadratic function. Very nice. Quadratics form a parabola. And then what kind of a function creates something that looks like that? Do you remember? Very nice. It's an exponential function. So we have a linear function, a quadratic function, and an exponential function, right? Now, can you look at this here? Can you tell me, I want you to imagine that this gets blown up here. Imagine that this, actually, I'm going to erase this and draw another one just so that we can... Okay, I want to blow this part up right here. Just this part right here and this part right here. What do you notice about those two if you just focused in on those two? They aren't the same. They just look very much the same. Does that make sense? I mean, if you just looked at just that chunk, what if on my table, the only part that I could graph was this piece right here and this piece right here, would you be able to tell whether or not it was geometric? Would you be able to tell whether or not it's exponential function or a quadratic function just by looking at that? No, because it's still going to be a curve, and you wouldn't know. I mean, if you did this section right here, I mean, for all you know, this guy's going to bounce right back up as soon as it leaves your seat, your point of view. Does that make sense? So then you wouldn't know. That's why there are rules. We're going to show rules here as to how to mathematically figure out whether or not the sequence or the data is representing a linear, quadratic, or an exponential function. Does that make sense? So, here's how it works. If I give you a table, and they usually turn them on their side here, could I leave it up? Could I leave it right side up? It would make no difference, right? Here's x, here's y. X's are always going to end up being consistent because why? Because you're the one who chooses them. You're going to put in 5, 6, 7, 8. You're going to put in -2, -1, 0, 1, and 2. You're going to put in something so that it's easy to grab. You're going to choose something that is consistent. So anyway, we'll just put it in here. 1, 2, 3, 4, 5, 6. It doesn't matter. If for y, I go -8, -5, -3, no, -2, 1, 4, and 7. What we're going to do, just like we've done many times in the past, is we're going to go, okay, we're going to check for what first? We're going to check to see if it's linear. We're going to stop using the word arithmetic because that's what got us confused yesterday. We're going to check to see if this thing is a linear function. How do we know if this thing's a linear function? If this is consistently addition and this is consistently addition, what do we know for sure? It's linear, right? Let's see. We all know that these are all +1s, right? We did that. We did that on our own. Whatever. We don't even need to do that anymore because we know it's going to be consistent. Down here, this is +3, +3, +3, +3, +3. Since they're all +3, that's consistent. That makes this set of data, these points on the graph, what are they going to form? A line. This is a linear function. Does that make sense? Okay. Let's try this then. Let's do this one. Here's the deal. You ready? Here's the deal. First of all, you look at this and you go, "Wait, this is really weird," right? Because you see that you see that it looks weird? Okay, well, let's check it out. First thing we do is we check to see if it's a linear function. Check this. Go -3 to -7, that would be -4, yes? And then here would be -2. Here is +0, and here is +2. Does that make sense? Now, looking at this, first of all, is this linear? No. Is that consistent at all? No. This is where, from right here, what you can do is this was the first set of differences, right? Those are the differences, and that's the first set. Now you look and see, is the second set. You take that first set of differences, and you're going to do it again. What is the difference between -4 and -2? +2. -2 and 0? +2. 0 and 2? The second set of differences are consistent, therefore, that makes this a quadratic function. And you can, because they did this, look here, because of this guy right here, you could see that, what does that tell you happened? This thing bounced. Does that make sense? It went from -7 down to -9, to -9, back up to -7. What's that mean this thing did? Is that it bounced. You see what I'm talking about? And so you already tell, just based on this one was an easy one to see that it was quadratic because it bounced and you could see it. But even if this will still work, even if the only part of this thing you catch is right here, before it bounces, it will still show you, it will still work, even if you don't catch the bottom or the top. Do you understand what I'm talking about? Okay, let's try this one then. Let's try, okay. What about negative 1, 0, 1, 2, 3, and 3, 6, 12, 24, 48. Here we go. First thing we're going to do is try to see if it's a linear function. Is it linear? Well, let's see. This is plus 3, this is plus 6. Boom, I'm done. No, right? While we're here, what should we go ahead and see if we can, what should we check and see if it is? Let's see if it's quadratic, because we need to find the second set of differences, right? We're already halfway through the first set of differences. Let's finish it. This is plus 12, right? And this is plus 24, right? Now, that's the first set of differences. Let's see it again. What is this? This is plus 3. This is plus 6. Boom. We already know now. What is this? Definitely not? It's not quadratic. Does that make sense? It's not a quadratic function. This is not a parabola. Let's go back then and see, what's the other option? Exponential. Put the second number over the first. That would be 6 over 3. This would be 12 over 6. This is 24 over 12. And this is 48 over 24. Does that make sense? These. What do they all equal? 2. Which tells you that it is an exponential function. Does that make sense? It's all times 2. The common ratio would be 2. Yes?
So when it's like multiplication, so like when it gets bigger, it's exponential, and it's quadratic when it's addition?
No.
Quadratic.
You just go down the list. You have to do the second set of differences, right? You have to actually do the instructions, right? So I guess I'll have you write this down. The first thing you're going to do, the first step is check for linear function. Do you all know how to check to see if it's a linear function? What am I looking for? That would be consistent, and I'll put a big plus sign, a consistent plus. All right? The second thing you're going to do is you're going to check for quadratic function. How do I do that again? Second set of differences are consistent. Consistent adding, right? Good. And then the third one is you check for exponential function. How do you do that? That one you take the second number over the first number and check for consistent multiply. Does that make sense? Does that make sense? Those are the steps. I've now handed you the blueprint to do this entire assignment. Okay? One part that I don't have you do a lot of times is this. They'll give you this right here. I could do this, but I won't for today. They give you this, and they'll go, find a good one. -2, -1, 0, 1, and 2. And it is 10, 2.5, 0, 2.5, and 10. By looking at that, first of all, what can you tell me this is? Why do you know? It bounces, right? You're looking at it, and it went from 10 to 2 to 0, back up to 2, and back up to 10. Does that make sense? You're looking at, you know this is going to be a parabola, which makes it quadratic. Something else that they ask you to do in here is they want you to tell what is this going to look like? What is this function going to? What is this parabola? What is the equation? What is the function? Right? And it would be y equals something, right? That's what this is going to be. This is going to be y equals, and it's 2.5x squared. Now, maybe I'll show you how to do this here in a second. Maybe I won't. I don't know. I mostly just want you to be able to do the successive differences and know whether or not it's a linear, quadratic, or exponential function. You guys can try a couple of these. Let me see what I give you for homework, and I'll give you the ones that aren't that. Okay. This is right now a little mini quiz. I want to know if it's linear, geometric, or not geometric, linear, quadratic, or exponential. What? 0.75. No geometric, linear, quadratic, or exponential functions. The questions I'm giving you are on the bottom of page 587 if you want to try to find them. All right, here we go. Let's see how you did. The first one, first thing we always do, check to see if it's a linear function. So you go, okay, this would be plus 2.25. Actually, hold on, I'm going to need to move this. Okay, 0.75, 12, 48, 196. Okay, this is plus 2.25. This is plus 9. Clearly not linear, right? And then we go, this is plus 36. And then plus a lot. 192, is it? Okay. And then that would be plus, oh boy, whatever, 150-ish. Let's just see if this works. Now that we're here, what should I do? I'm checking to see if it's quadratic. Is the second set of differences, so plus 6.75 plus 27, clearly not, right? So the only other option is exponential. Let's go see if that's true. Let's see if that's true. So I need to go back and put this thing as 192. Okay, this would be 3 over 0.75, and then 12 over 3, and then 48 over 12, and then 192 over 48. They all equal 4 times 4 times 4 times 4 times 4, which makes this exponential. Right? It makes it exponential. We all Understand this? Okay. The second one. Let me do it over here so there's room. The second one, does it look like it's quadratic just by looking at it? This looks like it's a quadratic just by looking at it. You see the bounce? You see it bounce? Does that look like it bounces? So it doesn't look like it's quadratic. In fact, this looks like it's being multiplied. It looks like it's going straight up, right? Like this thing, if you look at it, it looks like it's exponential. Let's check it out. The last one was linear, by the way. You should know that. Number 3 was linear. Here we go. This first thing, checking if it's linear, it would be plus 4.2, plus 12.6. Okay, clearly not linear. And then this would be plus, 21. And then this last one is plus 37.8, so 29.4. Looking at this, second set would be plus 8.4. This is plus 8.4, and this is plus 8.4. The second set of differences are consistent, which makes this quadratic, right? I'm telling you, if you saw the graph, all you're looking at is this right here. And you can't tell from just looking at this whether or not this thing's going to bounce or whether it's going to go like this. Do you agree? Therefore, you have to do the second set of differences to see. We found out, okay, this thing, what is it going to do? It's going to bounce, right? It will eventually bounce. Make sense? Okay. Let me give you your homework. You guys have 12, 13 minutes right now to work on it.